Welcome back to eCoreAcademy students. My name is Anita and I am one of the teachers and co-founders here along with my younger brother AJ Raj. Today, as you can see, we have a new Algebra 2 lesson for you, and we're going to be continuing factoring quadratic expressions. This is part 2. I'm going to cut off the factoring quadratic expressions with this video because I really want to get through the Algebra 2 series as fast as possible, and I'm trying to cut out all the fluff that you should already know from Algebra 1 or that we're already going to be seeing in practice problems or notes or practice worksheets that are all accessible on our website. So part 2, this is the last part. This is also very important because in this video we are going to cover 2 key concepts of factoring. They are perfect square trinomials and difference of squares. You might have no idea what I'm talking about, but once I show you the actual formulas and the layouts and how to solve these problems, they'll probably jog your memory. Oftentimes we learn these things, but we don't remember what they're called, or our teachers just don't put a name to that kind of problem. And then after we go over that, we'll look at a quick summary of how to factor. So I'm going to be breaking it down into easy steps that you can just run through whenever you're doing a problem. So you can have like a mental checklist when you're factoring. Okay, before I even get into the video, I'd really appreciate it if you hit the like button, also hit the subscribe button and post notification bell, and don't feel afraid to drop a comment down below. Lastly, please share using our socials. We really appreciate it if you do all of the above. Okay, now let's get into the video. So the first key concept, like I touched on before, is perfect square trinomial. So perfect square trinomials are a concept that will come up in factoring quite a bit. If you notice these concepts early on when you're solving problems, it's almost like seeing a pattern. When you see a pattern, it's easier for you to find the solution as in what comes next in the pattern. Just like that, with perfect square trinomials and difference of squares, which we'll be seeing next, if you understand these concepts and understand the basis, the foundational formula that they all follow, you'll be able to break these down very quickly. You don't have to waste time on your assessments and so forth. It just demonstrates a higher level math skill if you're able to point out, hey, this is a perfect square trinomial, or hey, this is a difference of squares. So that's why you always want to be on the lookout for these concepts. So this is what a perfect square trinomial could look like. A squared plus 2ab plus b squared equals the quantity a plus b squared. So let me just write it up here. So a and b can be any variable. Usually any number. Usually, I'm just going to write that here, a and b. Usually one of them is a constant and the other one is your x term. So constant, and then the other one is your x term. Constant is your x variable. If you look over here, you see the factor. So this is the quantity a plus b squared. So this is pretty much just the quantity a plus b multiplied by itself. Because remember, when we're multiplying a number by itself, one time we say squared. Just like if I were doing 5 times 5, I say 5 squared instead of having to say 5 times 5. So that's what you have to understand from this. So if I have the quantity a and b can be any number or a variable. If I have a plus b squared, so a plus b times a plus b, if I expand that and I distribute and I simplify that as much as possible, I will end up every single time with the quantity a squared plus the quantity 2 times a times b plus the quantity b squared. So if a is one value, b is another one, you just plug them into this a squared plus 2ab plus b squared and you will get that. So if usually you'll see the a squared plus 2ab plus b squared and you're going to be asked to factor that. So break it down into 2 binomial expressions. So what that means is that you should be able to identify if this is a perfect square trinomial. And we'll be doing that in the examples, but just keep an eye out for quadratic expressions that are structured in this kind of way. Next, I want to touch on a squared minus 2ab plus b squared equals the quantity a minus b squared. So as you can see, the main difference is this sign right here. There's a sign change. So this is a negative sign. Up here we had a positive sign. So how does that affect our factoring? Well, the 2 binomials we're going to be multiplying together. Instead of inside the parentheses, instead of there being a plus sign, we're going to instead have a minus sign. So this would be written out as a minus b times a minus b. So if you were to see a perfect square trinomial, and there was a negative sign in front of your 2ab term, you know that your factoring is going to be a minus b times a minus b. However, if you see a positive sign, you're going to know that you're factoring this as a plus b times a plus b. So that's just how you're going to do it. I know it might seem confusing now, but when we do the problem, I'll show you exactly how to approach these kinds of problems. And I just want to break down what perfect square trinomial means for a lot of you who understand concepts through breaking words down and understanding what different words mean. Let's do that right now. So perfect square trinomials are expressions obtained from taking one binomial expression and multiplying it by itself to get a trinomial of the form ax squared plus bx plus c. So what exactly does that mean? Well, let's look at the name perfect square trinomials. So let's break this down into two parts. I'm just going to draw a squiggly line through perfect square trinomials. So we have two parts. We have the perfect square part, we got the trinomial part. So what does each part mean? Well, the perfect square part is a perfect square. So what is a perfect square? A perfect square is a number that when square rooted will give you an integer value. So for example, an example of a perfect square root would be 25. So if I wrote 25, and let's say I wanted to square root it to prove if it's a perfect square or not. So the square root of 25, we all know that's equal to 5 times 5. Therefore, we know that 25 is a perfect square. If I had a number, let's say I took a number like 41. Well, 41 is not a perfect square because if I think about it, 6 times 6 equals 36, 7 times 7 is 49, 41 somewhere in between there, but it's not a perfect square. Two integers multiplied together don't give me 41 exactly. Therefore, this is not a perfect square. Well, 25 is a perfect square. Therefore, a perfect square trinomial is a perfect square, meaning your expression, which is a plus b or a minus b multiplied by itself, will give you this will give you the expanded form. So if I have a plus b times a plus b, I will get this. So this is the perfect square of the binomial a plus b. If I multiply a minus b times a minus b, I'll get a squared minus 2ab plus b squared. This is your perfect square of this binomial a minus b. So that's where the perfect square comes in. The trinomial comes into play where we're trying to understand binomials and trinomials. A binomial is an expression where you have two terms and they're separated by they're separated by a positive or negative sign. So you're finding the sum or difference of two different terms. In this case, it's either a plus b, as you can see right here, or we have a minus b. However, when we say perfect square trinomial, we're focusing on this part of this formula right here and this part of this formula up here. So the trinomial part is, you can see that there are three terms here, and they're each separated by either a plus sign or a minus sign. So that's what accounts for that trinomial. Tri means three. So there are three parts of this expression. You have that a squared right here. You have that plus 2ab or minus 2ab, and then you have the b squared in both scenarios. So that's how we break the name down. And then if you have an a minus b, if you have an a minus b binomial and you're a plus b or a minus b binomial and you're squaring it, when you simplify everything out, you're going to end up getting a trinomial of ax squared plus bx plus c. Like we've been working with quadratic expressions, you're going to end up with something like that. So that is the key concept. Now let's actually do a problem together. Here's an example of perfect square trinomials. Hopefully, if I walk you through this, everything I just said will make a lot more sense. So you'll see a problem like what's on the screen: x squared plus 6x plus 9. Looking at this, you might not know it is a perfect square trinomial, but it actually is. The more you work with these, the easier it'll be for you to identify them. So just keep at it, just keep looking at more examples, and then eventually you'll be able to tell. I'll show you exactly how you can determine this is a perfect square trinomial. So the answer to this, if I asked you to factor this, would be x plus 3 times x plus 3. This can also be rewritten as the quantity x plus 3 squared. For now, you can do it however you want, but eventually try to start writing it this way that I've written below. So try writing it like that. That will be your most simplified answer. So we want to know how to get there. So this is how exactly we would get there. Here's the pre-written solution. I always do this for those of you who like to see the solution beforehand, copy it down, and just follow along as I explain it to you. So go ahead and copy that down if you want to. If there are any corrections I need to make, I will make them while I am explaining and while I am writing out the actual solution in the together part. So I'll give you a second to copy that down if you'd like. Okay, hopefully you paused the video and had enough time to copy that down. Now let's actually do this problem together. So I'm going to rewrite the quadratic expression that we are trying to factor, x squared plus 6x plus 9. So how do we know if this is a perfect square trinomial? If we know it's a perfect square trinomial, it makes life so much easier because remember a squared plus 2ab plus b squared, or we'll be working with a squared minus 2ab plus b squared. In this case, if this quadratic expression were to be a perfect square trinomial, we would be working with this first one, not the second one, because as you can see, there's a plus sign right here, and we are working with a plus sign, not a minus sign. So I'm just going to draw a line through that. So this is what we would be working with. So first, let's determine if it's a perfect square trinomial. As you always want to do, you want to find you can't GCF anything out of this, and then you just want to go directly to your C term. You want to list out its factors. So we have 9. 9 is not a prime number, it's a composite number, but it has factors 1 in itself. It also has another set of factors, 3 and 3. So the C term, as you can see, the C term itself is a perfect square because the square root of 9 is 3. You get an integer value. 3 times itself is equal to 9. Thus, 9 is a perfect square. That is one indication. The next indication is these two terms right here, 3 and 3. Well, you could either have, if we didn't know that this was a positive 6, if it was either positive or negative 6, these 3's, when multiplied together, positive 3 times positive 3 equals 9. Well, if we remember that these terms added together end up giving you the coefficient of your b term. These two terms multiplied together give you your C term, them added together gives you your B term. That's what we reviewed in the last video. So if we had positive 3 and positive 3 multiplied together, they equal 9. Added together, they equal 6. Therefore, we'll have a 3 in one set of parentheses, and we'll also have a 3 in the other set of parentheses. So that's where we get the x plus 3 times x plus 3, because literally these are, you're putting the same number in both sets of parentheses with both x's. So that's where you can understand that this is a perfect square trinomial. Okay, so we know that this doesn't work because this is a perfect square trinomial. There's no way you can manipulate, add, or subtract 9 and 1 to get 6x, but you can add 3 and 3 together to get 6x. So how we know this because, like I said, 3 times 3 is equal to 3 squared, which is equal to 9, and 3 plus 3 is equal to 6, which satisfies our C and B terms. Therefore, how do we write this as an actual, how do we get to this part? Well, remember how we already know that it's going to be x, I'm writing at the top left of the screen, x plus or minus some value times x plus or minus some value. And we know this is true when our x is equal, when x is equal to 1. I mean, a is equal to 1. Here, a is equal to 1. So we know this is true. So it's just a matter of determining what goes here. It's always going to be a constant, as in this case. It's going to be a constant we have to put in there. And as we can see, positive 3 and positive 3 work. So that's why we're going to be putting x plus 3 times x plus 3 in as our answer. So that is how we answer that perfect square trinomial question. Okay, let's move right on to our next key concept, our second key concept, which is called difference of squares. So this is what it'll look like. You'll have an a value and you have a b value. You never know what they are. A and b are just terms, so your a value could be something like 25, could be 4x, could be literally anything. Anything that has to do with quadratic expressions. So let's just say we have an a value and we have a b value. We don't know what they are. In this case, if we have a squared minus b squared, it's equal to the quantity of whatever a is plus whatever b is times whatever a is minus whatever b is. So that's where you get the difference of squares. Remember, the sign between the squares cannot be a plus sign. I know this might seem a little confusing, but on the next slide, we'll be doing an example of exactly how to do these. So hopefully that will help you understand. So it's a difference of squares, and these expressions simply contain one squared number subtracted from another one. So let's break down exactly what that means. So we have a right here. A is a squared number. As you can see, it's to the second power. B is also a squared number, so it's also to the second power. Therefore, let's say we have a value a and we have a value b. I'm just going to give them random values. A is equal to, let's think of a small value, 3, and b is equal to 2. So a is equal to 3 and b is equal to 2. So what we're going to do is if you'll see something like this, you'll have something like 3 squared minus 2 squared. So we have two squares and we're subtracting one from the other. When we do subtraction, we're subtracting one number from the other. The answer we get is what's called a difference. You should probably know that from elementary school. So by subtracting two numbers, you get a difference. That's why it's called difference of squares. So if a was equal to 3 and b was equal to 2, how we would write this if we were factoring. Remember, these are like constants, so you could actually solve this. You could square 3 and get 9 minus 2 squared, which is 4, which is 5. You could solve that, but I'm doing this just for the sake of showing you how to write this out, because if one of these was x, like you're going to see that if one of these had a variable in it, you're not going to be able to fully solve. You just have to factor the expression. So let me just show you with these two numbers. So if I had a is equal to 3 and b is equal to 2, I already wrote this part, a squared minus b squared, which is actually 3 squared minus 2 squared. I could rewrite this by factoring these two out. I could rewrite this as a plus b, so 3 plus 2 times the quantity 3 minus 2. And you can see that this is true. 3 squared is 9 minus 2 squared, which is 4, so 9 minus 4 is equal to 5. And let's see if this side of this equation is equal to that. 3 plus 2 is 5, 3 minus 2 is 1, 5 times 1 is 5. So this is true. Because this is true, we know that this formula is also correct. So you can always follow this when you run into a quadratic expression where we have a squared minus b squared, where the a squared and b squared values are both perfect squares. You can break it down and factor it into the a plus b times a minus b. So that is difference of squares. Now let's go into an example, difference of squares. So we have this quadratic expression. We have 25x squared minus 4. As you can see, it's missing a b term. Usually with difference of squares, like you saw, it's like with a difference of squares, I'm just going to write at the top a squared minus b squared equals a plus b times a minus b. You see that you only have two terms. You have an a squared term and you have a b squared term. Just like you can see that you have two terms of 25x squared and a minus 4. So that's just going to follow suit. You're not going to have three terms. This is not going to be a trinomial. It's going to be a binomial. Okay, so we somehow factor that into 5x plus 2 times 5x minus 2. Some of you might be able to see how we did that without me even going over the solution. Some of you might not be able to see that, and that is perfectly fine because we're going to be doing the solution together. So here's the solution pre-written if you want to take a moment to copy that down. I'm going to be going through the exact same thing with you, but like I said, if you're someone who likes to write everything down first and then listen so you can focus all your attention on listening, go ahead and do that. I'll give you a second to pause the video. Okay, hopefully that was ample time. So now let's do this together. So I'm just going to rewrite this quadratic expression we've been given, 25x squared minus 4. I also want you all to take into account, even before we start breaking this down, how it's separated by a minus sign. Remember on the last slide where I said that if you have something that is a perfect square and you have another term that's a perfect square, but they're separated by a plus sign, it is not a difference of squares. Difference means subtraction. Therefore, it needs to be separated by a minus sign for this to work. You're not going to be able to use this concept a plus b times a minus b if there is a positive sign, if there's a plus sign here instead. It must be a minus sign. So keep that in mind. It might trip you up on assessments, but please don't get confused with that. It must be a minus sign, because I know I've made mistakes like that before. So remember, minus sign, not plus sign, even if both of the terms are perfect squares. Okay, let's break this down. So we have 4 by itself, it's a constant, but here we have 25x squared. So this together is one term. However, the 25 is the coefficient, and then x is the variable. So let's break each of these down. So 25 we know is a perfect square, because it is equal to 5 times 5, which is 5 squared. How about when we look at x? Well, x squared is also a perfect square because it is equal to x times x. X times x is just equal to x squared. So we're combining this 25 and x squared to make one term, which is 25x squared. So I'm just gonna write that up here. So we're combining these together. As you can see, the square root of 25 is 5. The square root of x is x. So we make this new term 5x. 5x times 5x is equal to the 25x squared that we're trying to get. So see how we square rooted each part of that term and we combined its principal parts, and we made new terms. So 5x times 5x equals 25x squared. So we know that the square root of 25x squared is equal to 5x. Well, now let's look at the 4. 4 is also a perfect square. 4 is equal to 2 times 2. So 2 squared is equal to 4, making 4 a perfect square as well. So we need to combine all this information to factor this. So in this case, you see that this is a squared minus b squared. So your a value here, if you're trying to apply it directly to this 25x squared minus 4, you might think that the a value is equal to 25x squared. That's probably what you're thinking right now, and that the b value is equal to 4. Well, I gotta tell you, that's wrong. Look here how it says a squared minus b squared. 25x squared is equal to a squared. 4 is equal to b squared. 4 is not equal to just b. 4 is equal to whatever b is squared. 25x squared is not equal to just a. It's equal to a squared. So how do we find the value of just a and b? How do we find that value? Well, you have to square root both sides. So if I square root both sides, the square root of a squared is just a. Square root of 25x squared, as we said over here, is 5x, because 5x times 5x is equal to 25x squared. Square root of b is just b. And the square root of 4 is 2, as we said down here. So we know that a is equal to 5x and b is equal to 2. Hopefully that misconception is cleared up, because I don't want you guys to get tripped up on that. So we can directly apply this to the a plus b times a minus b. So a plus b is just going to be 5x plus 2, because 5x is our a, 2 is our b. And then we have a minus b. So again, 5x is our a, but then this time we do subtraction, and then we have our b term, which is 2. And that is how we got to the answer. So a difference of squares. By the time you get used to doing these problems, you'll actually be able to do them mentally, which is the point that I got to. I was able to see a quadratic expression like this and say, hey, 25x squared square rooted is equal to 5x, hence 25x squared is a perfect square. 4 square rooted is 2, hence 4 is a perfect square, and you see these two squares are being subtracted from one another. Therefore, it is a difference of squares, and I can immediately apply the quantity a plus b times a minus b, and just easily factor that. So You'll be able to get to that level. Just keep doing problems like this. Hopefully this was a good explanation. You won't have to do this much work when you get used to it, but I suggest writing everything out so that you just know what you're doing. You can keep track of what you're doing, and so you especially don't get confused with things like what we did up here. So this ax squared, this a squared, b squared, ab stuff that we did up here. Okay. I just want to quickly do a summary of factoring before I end this video. So first, you want to look for a GCF. Remember, GCF is your greatest common factor. You're especially looking for this when your a value is not, the absolute value of your a value is not equal to 1. So if you have an expression like 2x squared plus 3x minus 5, something like that. I'm just making it up off the top of my head, where your a is not, the absolute value of your a is not equal to 1. So you're trying to GCF it so that you can get your absolute value of your a to be equal to 1, and then it'll just be so much easier because you can just factor it normally. So first, you're looking for a GCF. Then if you find a GCF, you want to factor the GCF out of the expression like I just said, so the absolute value of a is equal to 1. Then after you do that, you want to check to see if whatever you have left. So let's say you GCF that number out, and then you have your a value equal to 1, and you're good. Your absolute value of your a equal to 1, and you're good to go. Then you want to see if whatever remains after that is the following. So you want to see if whatever remains is either a perfect square trinomial or if it's a difference of squares. So remember, perfect square trinomial is a squared plus b squared. Sorry, not b squared. Let me just erase that. Is plus 2ab plus b squared is equal to a plus b squared, the quantity a plus b squared. So you want to see if whatever is left is this perfect square trinomial or this kind of perfect square trinomial. A squared minus 2ab plus b squared equals the quantity a minus b squared. If it's not a perfect square trinomial, you want to see if it's a difference of squares. Like we just said, a difference of squares is a squared minus b squared, and you will end up getting, after factoring, a plus b times a minus b. The reason I say look for these is because you've been given a formula. You've been told that if you have a perfect square trinomial that is a squared plus 2ab plus b squared, immediately you're told that the factors are a plus b and that quantity squared. You already know those. That's why I'm telling you, look for a perfect square trinomial or a difference of squares first, and that will save you so much time because you already know the formulas. You already know how they're structured because that structure will follow every single perfect square trinomial or every single difference of squares. If whatever's left is not one of those things, then you can just factor the remaining trinomial completely as you normally would. You want to take C, whatever C is, and break it into its factors, and then you want to add or subtract these factors to get B. So you run through your factors for C, and you see, do I need to change any of these signs to a positive sign or a negative sign? Do I have to add or subtract these factors so that I can get my B value? Because remember, when we put it all together, your two, when you put it into parentheses, like I showed you before, and your factors, you'll have A plus or minus some value times, x, and then x plus or minus some value, and these two will be multiplied together. So this sum value that I'm saying would be your factor. So these two sum values would have to, when multiplied together, equal your C, and when added or subtracted, get your B value. So that is how you would do that, and then you would just put your answer together. Normally, you would write it as two binomials or whatever scenario. Usually, it'll be two binomials, or else you'll have a GCF sitting outside in the front. You have different scenarios, but usually two binomials. If you cannot factor at all, you just have to write not factorable. You'll run into scenarios like that, but that's just how you would put your answer together. Okay, so that's all for factoring quadratic expressions. That is it. We're not going to be I'm not going to be teaching you how to factor quadratic expressions further. You should hopefully understand them by now. They're pretty straightforward, and you can find a lot of practice problems to do if you're still struggling. So in part 1, we went over some concepts, and today we continue those concepts by putting names to different kinds of scenarios that you might see. So that's all I have for you today. I hope you enjoyed the video. If you did, please like the video, subscribe to the channel, hit the post notification bell, drop a comment down below, and share using our socials, Facebook, Twitter, and Instagram, all in the description box down below. If you have any personal or business correspondences you'd rather not convey through a comment, please email us at eCoreAcademy@gmail.com, which is also included in our description. Lastly, we have a website coming out, which I know I keep repeating, but it has a bunch of sweet functionalities for you students with courses organized exactly how you would go through them in a school, along with notes and practice assessments for you all. And you'll also have access to all of these videos to just help you along if you're trying to refresh, if you're trying to get ahead, if whatever you're trying to do. eCoreAcademy is here to help you. Okay, have a nice day, and I'll see you in my next Algebra 2 video. Bye!